just start the stream and see if others join, and we can see. Let's start with p5.js, which is library, a JavaScript library that lets you visualize stuffs in a very easy way. So if you're a JavaScript developer and you want to build some visual things, like maybe a game like us right now, there is this library called p5.js, which okay, I will just read it out. p5.js is a JavaScript library for creative coding with a focus on making coding accessible and inclusive for artists, designers, educators, beginners, and anyone else. p5.js is free, open source, because we believe software and tool or to learn it should be accessible to everyone. Using the metaphor of sketch, p5.js has a full set of drawing functionality. However, you're not limited to your drawing canvas. You can think your whole browser page in your sketch, including HTML5. That's p5.js, and p5.js offers an online editor which you can access here, which was already open here on my first tab. So there, and then you can also integrate it, p5.js on your JavaScript code. Here I think the download, it actually allows you to download the editor as well if you want to work offline. And it has these library files that you want to include if you're working on your own without the p5.js editor on the browser. So let's see what it offers you to begin with, which it allows you to work in a manner where you have functions you define which does specific job for you, and on your sketch you will see this is usually what you see. There's a set of function that you define which has everything you want the program to run when it starts, so like your initialization function. And then there is a draw method, draw function, which the whole thing is running in a loop, and then draw is called every time the loop iterates. So for every iteration, draw function is called once. That makes it really convenient for us to develop an app or something where you have things moving around, and you can think of a game on canvas where your character is moving, and all you need to think of is their position and things like that. But the engine itself that puts the things in motion is there. Let's begin by just coding something, right? So this is the default code we get when we start a new sketch, and there is this create canvas function which creates a HTML5 canvas, and then inside draw function we're just calling this background function, which obviously puts a background color to your canvas. And I'm not sure about 220. It seems like it's a gray value of white. Say, yeah, 0 white is a black, and 255 is a white. So yes, so if I want CCC, oh no, sorry, not CCC, 222. So that's the amount of gray. I assume you should be able to give RGB as well. Let's see if this gives you red. It does. So if you have 3 values, it's RGB, and if you have just one, it's gray, or intensity of white. That's background. So I personally have no experience with P5 whatsoever. Other than a few years ago, I was doing ML5, which is another interesting library. ML5, which is a machine learning library for a browser. So ML5 allows you to do it uses TensorFlow. It allows you to train your model. Like you can use built-in or already available models to do classification or these machine learning AI tasks. It's a quite interesting library, and it also allows you to use it's basically the examples use P5.js. I don't remember exactly all the details, but it used P5.js to do the rendering and all those. And that's when I came across P5.js, and I think it's a nice little library. And I also work with Arduino, where you have similar approach of writing code. There's a setup function and there's a loop. And as mentioned earlier, like in P5.js, the loop, the setup function is called once when the application starts, and then the loop runs for every, say, it just keeps looping on itself. And whatever you want to do, like if you want to read sensor value, you call some read function, let's say basic Arduino sensor read and log. There should be enough examples. Read analog signals. So there's the loop function, and what they're doing is they're reading analog value from a pin and then setting it to a variable called data, and then logging that to serial and adding delay of 1 second so that it only does the reading every second. You don't want to flood the log with lots of readings, so that's why you add those delays. And same concept is here in our P5.js. To call them, just call the function's name and then give them coordinates. So right now we have canvas size of 400 400. Let me write, or let me draw a circle at 200 200 with radius of 10 pixels. This should draw it. Yes, it did. So there you can see in the center you see a circle. I think you can also draw a rectangle. Give it the coordinates. So say 180, 180, width 50, height 50. I think that's it. Oh, that's too big. Let's say 10 and 10. So because I haven't used any color there, um, we see just white fill and black borders. Let's try fill. I am not very certain, but let's try this. 20000. Oh yes, yes. Um, Interesting. So I called fill after a circle, but it did also fill the circle with that color. So I assume it doesn't matter where we put this fill. Oops, I'm trying shortcuts for my code editor, but this is a online editor, so I should not forget that. I'm using um, a keyboard from a colleague, and I'm not used to it. It's German, and I have to look at the keyboard all the time, which is Command X and Command Y. Okay, fill is fill, background is background, and let's say stroke, maybe stroke, or I think it should be stroke. I don't think they will call it border. So 00, maybe 10, only 10, green 2220. Yes, that's how we add stroke. So we have stroke, we have fill, we have background, we have circle and rectangle. So what do we build now? I was thinking about Flappy Bird, which is a very simple game. Let's start to add gravity. So the bird is right now in the middle, it doesn't fall. It's supposed to fall, right? Not very important, but I would like the bird to be a little bit on the left, like this, or a bit, maybe 150. Yeah, before doing all these, I would just add these to a variable width and height, just height. Width 400 seemed okay. Const height equals 400 is also fine. So that's our width and height, and let's this was the color and background, and here I would use the portion of width, like width by 3 or something. Yeah, that looks good. And to center it vertically, or wait, this is not going to be static. So the bird will just stay exactly on the position on X, but it will fall and it will jump, and it will just move on Y-axis. So Y should be dynamic, and we can call it a bird position, or position bird Y, or because it has no X, we can just call it bird position of bird, and for now 10 is fine. Now position of bird, let's start by just wait, let pose bird. Position of bird is 200, right? Which means it will be centered just like it is right now. That's it. And now because if we don't do anything, the bird has to fall down, right? If the bird needs to fall down, we need to add these velocities. So in these when you're working with canvas and drawing um, these images in those iterations, you have to add velocities, like how fast is bird moving on which direction. So let's give it a velocity of bird. So this is bird. How fast is bird moving on which direction? And let's say start with 0. The velocity, okay, let's give it 3, which means, and we need to be specific with the direction, and right now the bird needs to move only on y-axis. We can have we can choose one of the direction, up or down, as a positive. So since mostly the gravity will pull it downwards, so let's say the velocity downwards is positive, so call it velocity of bird downwards. So what 3 means is this is right now it's arbitrary number. What we can do is use that number, the velocity at which the bird is moving in this particular direction. We can change the position of bird for with that. So for example, position bird will just increase. Right now it's at 200 pixels from top. It will just increase by whatever velocity it has, right? Which means if the velocity is downwards and 3, it means for every iteration or for every loop, for every call of draw, it will move bird by that much pixel downwards. Let's see. There you go. So it's just moving flat 3 pixels per frame in downward direction. 3 pixels per frame. That's the rate, right? So also this is not really natural because nothing falls like that other than feather or balloon or something, right? Just because gravity, when gravity acts on something, you get an acceleration. Anything falling down will accelerate with time, right? So which means we need to add velocity every frame. So from here, let's say our position is done and we take care of gravity and all the physics at the end, right? Let's say physics. So to add acceleration, I don't think I will ever use this console here, but yeah, nice. So physics, what physics does to the velocity of bird is it increases the velocity with time, which means for now our time is frame. So every frame the velocity will increase, and downwards is positive, right? So velocity bird should be increased let's just increase by 1 and see if, oh, it did. Oh no, it doesn't look really good. Okay, so this acceleration is too huge. It doesn't look natural again. So plus plus is too much. Let's increment by smaller values, like 0.5 or something. Okay. Oh, sorry. Plus equals. Yeah. Still feels really heavy, right? So let's try 0.3. Okay. I would say I would say it could go 0.4. Okay. Yeah. This looks fine to me. Right? Okay, at least we have falling bird. Not yet Flappy, but falling bird. What next? So we want keyboard events, like keyboard press events, key press events, to push the bird upwards, which can be done by changing the velocity of bird upwards, like minus something or so. Yeah, but let's first find out how to add a click or key press event. I have never done, or probably I've done, but I don't remember. So let's go to reference and see if we can find events, key pressed, key down. Okay, let's use key pressed. Yes, so yeah, like we have draw function for the loop, we have key press function, this is nice, function for the events, which is really nice. It makes it so much easier to work with JavaScript. Let's check function key pressed or key pressed. I don't remember. Key pressed. Function key pressed will this thing will trigger every time you press the key. Let's say now I'm going to use the console. Let's log something. Yeah, 0 is fine. Yeah, 0. So whatever I press, it's logging 0, right? So we have our key press. So it doesn't matter what we press. I just want the bird to fly upwards, right? Which is done by changing the velocity. So the bird's velocity needs to be negative, and going upwards it should be with some velocity. I'm not sure what is the correct value, but we will just give some arbitrary numbers for now. Oops. In order to save sketches, okay, I don't know if I do have a count there, but okay. Oops. And no, what? Okay, I have to pause the game for a second if I want to be able to press it quickly. Okay, let's So let's still try it. Oh yeah, there. So I can press any button and it jumps upward. um, well, this looks like it's jumping too high. Or is it fine? Is it fine? Yeah, we have jumping bird now. I didn't think it would be this easy. So -10 means that now the velocity of bird is upwards, in upwards direction, with 10 pixels per frame. So which means for every frame, every iteration of the frame, it will try to go 10 pixels upwards. And and we have our gravity here, physics, right? So we have physics that is pulling it down by 0.4 pixels. So what happens is the 10 will decrease as it goes up, and then becomes 0 at some point, and then it will not move anymore, and then it starts falling as it keeps adding to that number. So -10 will become like -9, -8, -7, -6, -4, and 0, and then it will start adding 0.4, 0.4, 0.4, which becomes greater number, and it pushes it down with an acceleration. Okay, we have jumping. Oops. Yeah, this is tricky to start. Oh yes, now there it is. So I think I will. Yeah, this is fine. This looks just fine. Okay, now we have a jumping ball. What do we do next? Let's say if the bird is has touched the ground, let's not push it down anymore, because right now the bird goes down and it falls in the like infinite space. So let's say we want to check if we have touched the boundaries of the canvas. So position of bird is this only if pose bird is less than height. Yeah, if position of left high, else 0. Okay, this is okay, it fell down and now it doesn't come up either, which is the problem. So it went out of bound, but then when I press key, the velocity changed. The velocity changed to minus, but it couldn't come up because now the height is less than that, so it's not changing the position of bird at all, which is not what we want. Anyway, this was not needed. I was just I didn't want the bird to fall very infinite. Well, bird. Anyway, this is fine for now. We can still rescue the bird if it's falling down. Okay, now what do we want? We want those tubes on the so right now what's happening is the bird is flying in X direction, but because the camera is following the bird, it seems like it's stuck on the X axis, but it's still moving, right? So not yet, but we can do that. we can say forward motion, right? Like velocity of bird is the bird's velocity um, going downwards, we can have a forward velocity, right? Velocity forward, uh, like the bird falls, but we can have uniform velocity on x-axis because bird can fly in a uniform velocity. So let's say let's start by 3 pixels. It's fine. Let's say 2 pixels, right? 2 pixels per frame. So it will just we will assume that it's moving in 2 pixels per frame, but what exactly we do is we will instead move the environment 1 pixel and the bird will stay there, which will make it feel like the bird is moving forward and the camera is following the bird. So we will need to move the environment backwards, right? So we don't have anything on environment yet, but as we saw, we could draw rectangles. We can simply draw a rectangle here. Sorry, rect. For now I will just use 100, say 100 as well from top, and width 50, height 50, 60, whatever. Let's just draw this and see what happens. Yeah, there's a big rectangle now. So what we want to do is move this rectangle. Let's assume it's an environment and it's somewhere stuck, right? That needs to move with our forward velocity, right? And on the x-axis. So this x100 is not going to be static like this. It's going to be say we need to start it with 400, right? Because it's on the right, and then it will move towards left at the rate of that velocity forward. And for that, let's also let's position of block something. Pose block equals we start by width, so all the way on the right, and then we will move along the x-axis at the rate of vel forward. So that needs to be pose block, and that needs to be updated like in our pose bird's case. Pose block, so it should be in this case it needs to go left, so we will add reduce its position by vel forward. Okay, vel forward, da da da. So there will be no. Oh, it came a little late, but it's fine. There you go. Okay, now it looks like our bird is flying on the right direction, right? Okay, so let's put the block on the top. Y equals 0, and then yeah, so those tubes are going to be on the top, and yeah, so we will have to draw two rectangles, but they will have same x position, Y position will be different. Y position will be 400, for example, and not 400, but width minus, no, just height minus, for example, right now let's make it 50, and then its height will be 50, width is always 50, and on the top it will be 0, and let's see how it looks now. There you go. Oh my gosh, again, ooh. Okay. I don't know how to fill different drawings with different color, because when I tried fill just before, it actually filled for both bird and both rectangle and the circle. Let me try it again. So we already have the circle, but we don't have the blocks yet. Oops. Now let's see. Oh, there you go. Nicely done. Okay. Because our Flappy bird is yellow, let's make the circle yellow as well. Maybe orange. 200, 200. Maybe this. Oh, bird. Maybe 100. Okay. 250. Okay. So we have our bird. We have our blocks. Okay, wait. Nice. Now these blocks need to be multiple, and their gaps have to be on different position. So let's well, we need to randomize the Y position of the gap, right? Let's call it a position of gap. Random for now. How much? Random 100. It can be all the way on the top, about let's, to keep it simple, let's have it always same space, same amount of gap, so that it's easy to draw for us now. Let's say we just use the center of the gap. For example, it can be from 100 to 100 to 1 minus 100, height minus 100. So that will give you 300. 100 to 300. And then here, for position of the gap, what we want to do is the rectangle on the top will have this 50 pixel distance from that top, from that random position. So the position of gap is somewhere. We want our block to be 50 pixels behind that or above that. So X, Y. Y is, so the top one will always be on the top, and its height is determined by height is determined by the pose gap, right? So 0 to pose gap minus 50. That will make it that will make the gap 100 pixels, and for bottom one it will be not height minus 50. Y position will be x, y, and then width 50, height. Okay, now here for the bottom block it will be trickier. It needs to start from the position gap plus 50 pixels. So start will be pose gap plus 50, and then width is always 50. Height is going to be height minus how much? Pose gap plus, right? The total height of the screen minus the pose gap plus 50 pixels. Minus 50, which means yeah, let's see if that worked. Oops, there's an error. Pose gap is used before declaration. Where? So it couldn't find random. Okay, seems like I need to include some other library for that. But instead of going to find the library, I will just define it here. Function random min max min return math dot random min plus math dot random min plus math dot random max minus min. So this should give us the same result. There you go. See? Yeah. So it's drawing those tubes on a random position, right? And it's always same amount of gap between them. Random? No. Anyway, that's a strange error. So we have our own random function. We are drawing the tube in a random now what we want is those tubes to repeat, like they for now let's say we only show one tube at a time on the screen, and just repeat every time. So for that we will have to reset the position of the blocks from once it's past the left side of the viewport, which means if so where's our rectangle? Post block. Where's post block defined? Here. So if the post block, we want to add this if statement here. If post block is less than 0, maybe we want to wait until it's gone all the way, but let's try just using 0. If that is less than 0, else if post block is less than 0, post block equals worst, right? So once it probably it touches and it already resets. See, yeah, it touches and it already resets. So that is why we want to add an offset of -50 pixels, because then it allows it to let the whole block pass. Let's see now. There you go. So one after another. But right now the gap position is not being updated. Gap position is always one that it got assigned in the beginning. So to fix that, as it passes all the way to the left, we want to also change the post gap. Right, post gap will change again. Now let's try this. There we go. Came down there, down there, up there, down there. Yeah, so now it's randomized, right? So it looks like this jump is way too high. We want to reduce that now because it seems like I can't pass any one of those gaps without touching it. It's okay, it's the harder version of Flappy Bird anyway. Okay, so either we need to increase the gap or the jump needs to be smaller. Let's try by doing both. No, not doing both, because the gaps are all kind of... Okay, let's also refactor that so that it's easier for us later on. So these 50s are there because our gap has to be 100 pixels. So what we are doing is we are using the reference at the center of the gap. I'm showing it on the screen right here. Center of the gap, and then we are pushing those blocks 50 pixel outwards, which will leave this 100 pixels gap in between those blocks. So for that we can define a constant here for the height of the gap, and gap height gap equals 100. So we have 100 gap height. That is why we want to 100 is here because we want the gap to be at least 50 pixels below the boundaries. We don't want the gap to be all the way on the top, right? So that's why. we can just call it gap, height gap, right? And height minus this one is height gap. So the total height minus height gap is the position where it's the maximum position on the bottom. Here, position of the gap random 100 is also the same thing. We just copied and pasted this. So let's just copy it again and paste it again. This is like initializing or randomizing the position of the gap again. And velocity forward, position block. Here, the top rectangle, it needs to be like dynamically on x-axis, all the way top on the y-axis, and 50 pixels wide. This could be also constant, and on the y it has to be position of gap minus gap height gap by 2, so half of the gap. So the top block will leave half of the gap's height, so 50 pixels, and the bottom block will start on y-axis at position gaps position plus 50 pixels, which is the half of our gap height gap by 2, and its width will be 50 pixels and height will be the total height of the screen or the viewport minus position gap is the position minus half of it, half of position height, minus height gap. Yeah, so that's our math. So it didn't change anything, but now we can change the position height of the gap easily from the settings here. So we can make it really narrow, like 10 pixels. Sorry for that. 10 pixels, only 10 pixels, right? And it appears there. So it will randomly appear on any position, but with only 10 pixels gap. We want, if we want, we can make it 200 pixels, which is huge, but we can. Right. Okay, now this is easier. Right. Now this is easier. It almost looks like it's always on the center, because we have chosen to have them at least half the gap's height from top and at least half the gap's height on the bottom, which means for 200 pixels gap we have 100 pixel on the top and 100 pixel on the bottom, which makes it 400 pixel, which is our height, which means the gap will always be in the center, right? So 200 is too much, 100 is fine, and then what we can do is our jump is too high. We want to reduce the height we jump. See? So let's key pressed here. -10 seems a little bit too much. Let's try 8 and see. Where's my bird? Okay. Okay, now. Not bad. But it makes it really easy to play. Not so easy. Maybe I'm too bad. But it... Okay, I think it's fine. It's too hard for me, but probably there are people who can manage it. Yeah. Okay. Awesome. So, what next? Now we need to collision detection. Fancy. And collision detection should not be too hard for this one, because we know the position of the center touch. So there's 50 pixels of this width where it can be, it's possible that the Flappy Bird is going to touch those blocks. So if the X position of the block is between this wherever our Flappy Bird is, our Flappy Bird's X position is width by 3, right? So when the block approaches this X position, we need to check if the bird is touching it, right? So to check if the bird is touching it, what we can do is we can check the Y position of the bird and position of the gap, and if they are too far away, so if the bird is more than 50 pixels away from the center, it's obviously touching the block, right? So that's the logic. And for that, what we want is we want collision detection. All right, here this is looking really messy, and I will just zoom out a little bit. I hope it's fine. I hope it looks fine. Anyway, it should look fine. So now also I will drag this a little to the right. Okay, so that we have a little bit more space. Top block, bottom block. Now we have collision detection. So for collision detection, we want to track the position of the gap, right? No, not the position of gap, but position of the block. If position of block is less than or equal to width by 3, right? So when it's less than this, we want to check what the position of bird is and what the position of gap is, right? So let's just pose bird, comma, pose gap. Let's just try this and see what we get on the log. See, we're seeing some log exactly when the bird approaches the blocks, and position of bird is yeah, 283, 144. Okay. Yeah. So we want to find out if the bird's position is way away from the center of the position gap, gap's position. So if position of bird is less than or equal to, let's say, position of gap minus height gap by 2, right? So if the position of bird is less than position of the gap minus half the height of the gap, that's a collision. Or there's another condition. If the position of bird is greater than, if it's touching the block on the bottom, it's going to be higher. The position is going to be, position of bird is going to be higher or equal to gap's position plus height of the gap, half of height of gap. So this will give us it collided. Here I will just say boom. It makes the sound boom. Let's run it. It's all boom because my bird is somewhere. I don't know. Where's my bird? Okay, restart. Okay, now 94 booms, 112 booms, 123 booms, 139 booms, 145 booms, 151 booms. Okay, oh, $190. Wait. It's not enough for it to be less than equals, because it went left, but at some point it's out of the bird's X position. Then bird can go up or down. It won't touch the block. So this needs to be, if position of block is less than width by 3, and pos block is greater than, right? It width by 3 minus 50, which is our block's width. So let's see. So now 25 booms, Oh, come on, where's my bird? Okay, that was 75 booms. Come on, not too bad. 100 booms. There, 108. Only 8 booms. Ah, 117. Whoa, 117. I survived that one. Oh, now I hit. We have our collision detection. So now, once this bird collides, what we want to do is we need to set the state of the game as game over. What do we do for that? We need a state for game, right? So here, let let's call it progress. All this needs to be done only if the game is in progress, right? Okay, not fill, not the background itself. So background is always there. Maybe we could actually. What happens if I remove the background? I hope it doesn't. Yeah, see? So if I don't do the background, it will just keep all the drawings on the canvas. So I need the background. And fill and whatever, all these are only for when game is in progress. So if game state equals progress, so when the game is in progress, we want all this to happen. Else I'm not sure about text, but let's try it for the first time. Width by 2 minus 100 height by 2. Interesting. That's fine. Text word coordinates, right? So width, height. Okay, let's see now. It's still printing boom. Here, game state equals over. This is what needs to happen. Game over. Play. Game over. Oh, survived. Damn it. Okay. So I want to restart the game if the game is over. Here, if game state equals over, game state. Okay, let's see if it just works. Game over. Okay, I'll need to reset the whole thing. if I want to be able to resume the game. So here these initialization stuffs like position of bird, position of gap, position of block, and all these are initialization values. So let's copy all this. I don't want to use, I don't know, actually we can't use the lets. Here let's define our game initialization, game init function, which does all these. Oops. And now all I need to do is initialize the game. Oops, game over. See? Now we have a, once the game is over, oh, it didn't touch. I think the collision detection can be improved. Let's just kill it. Yeah, if it does, yeah. So if the game is over, I can press a button, a key, and then it will start a new game for me. Nice. So we have working game already, but what's missing? Oops. It's missing scores, right? So I should be able to keep scores as well. For now, let's define another variable, let score. So we can remove all these initialization stuffs from here. Oops. Oh my god, this using this keyboard has proven to be more challenging than I thought. Yes, so all this can be now called during setup, right? And it still should work. Oh, it's game over. Game init doesn't okay, this one here, let's move that to our init, right? So now the setup function will initialize the game, and right. Okay. So scores. We need to keep scores. Let's have a variable called score, and then here, game init, we also want to reset our score to 0, and you see here, every time a block passes the screen, you will get a score or collision detection. Once it passes this, for easy way for us, what? I think I need some more. The easiest way right now is to this. If the block has passed all the way to the left, add a score. Alright. Now we also want to show score somewhere. For now we can also show score here. Game over. Oh, come on. Score. Yeah, we can use template literal here, but for now I'm just doing this. Height by 2 plus 100, 10, 20, 20. Yeah, score 0. Let's try to score at least 1. Come on. Oh my god. I think I'm getting good at this. Oh, there you go, score 6. We also want to show the score on the top of the screen here. Not game over, but score plus score. Height 20 maybe. Okay. There you go. Scores updating as well. Score 2. Oops. There you go. Okay. Now, I wonder if I can use like anchor point for texts. Yeah, right now these uh, texts are weirdly aligned. Easy one here for score, at least it can be just 2020 and it should be on the left and wouldn't look too bad. Yay, okay. So, how do I increase the font size? Uh-huh. Text size. Where were we? Here. Let's say 44 and see. Ooh, everything is too huge. 44 is huge. 34 should be fine, and then once we have written the game over text, then it can go back to 16. Okay. Game over. Score 0. Font family, text font alphabetic. Okay. Anyway, that was Flappy Bird. We can now look at using sprites. I actually forgot to drink my tea and it's cold. Let's go back to Flappy Bird. Let's see how they show score. Ah, they have a cute way to show scores. Um, White text on the middle. Can I have stroke to the font? Let's just try. Wait, font. Stroke. Stroke, text font, fill, stroke, stroke weight. Okay, I think I have already set stroke somewhere, but it didn't have any effect. Where's our stroke? We don't? I thought we... Yeah, there's stroke for the circle and the blocks. Okay, that's because we haven't used any stroke. It's default black. So let me try stroke here. And now red stroke everywhere. Nice. What do we want? We want black stroke. We want black stroke, which is 0. Now let's try. There you go. Stroke weight or width. Don't remember. Stroke weight 4. Ah, looks nice. Stroke weight 4. This is strange. M has a horn. We want our score to be shown above anything else. So this needs to be after. Also, we want to show it only during the progress, not once it's over. So there, here. Nice. And also text here, I want to fill it by white 255. Also stroke weight here. Let's add that here. Black stroke with weight 2. Then our texts are white. Game over. The game over text there, yellow with black. Game over. Um, 230 100 0. Orange. Let's make it 180. Yellow. What's the background color? Blue. Sky blue. Our background has been this. Let's make it sky blue. Red value 0. Maybe 50. Green value 100. And blue value 220. Dark. 100, 200, 250. There you go. Let's make strokes a little bit lighter, about 50. A little more, 100 maybe. Right, now they look like soft, nicer. Awesome. No. Okay. Game over text. Can I make it bold? Text style bold. This will make our game over text bold and everything else too. So that's why we want to switch back to normal once we have printed the text. Game over. game over is bold, score is not. Alright. Let's move the score text a bit towards the bottom. Maybe make it 50. And also, if the bird falls down, we should also trigger game over. That's, I think, basic. So let's just do that. Okay, it can be outside as well. If whatever I wrote there, bird's position is greater than equals height, we also want to change game state to over. There you go. If you hit the block, it's over. If you fall down, it's over. If you go way up, that's also game over. So if the bird goes falls down, or if it flies way above the viewport, is less than 0. If bird is position of bird is less than 0 and greater than equals height. Now that should trigger game over for this and this, this and this, and then this, and then not for this, not for Okay, that's all. 2.5 hours of stream, not so many viewers, but we made a Flappy Bird game, and it's not a lazy Sunday morning anymore, because it's already afternoon here. And that was all. So if you're watching this in the future, thank you for watching, and please leave a like, a comment if you want to the video, and subscribe to my channel for more fun content like this. I will post all the code on my GitHub. Yeah, that's it for today. I will see you soon on another video. Wow.